This video is about empirical and molecular formulas. By the end of this video, you should be able to differentiate between empirical and molecular formulas. You should be able to calculate empirical formulas from lab data, and you should be able to calculate molecular formulas from lab data. Let's start by defining these terms. The empirical formula is the simplest whole number ratio of atoms in a compound. The molecular formula is the actual ratio of atoms in a compound. For example, C2H6 is a molecular formula. If we reduce to the smallest whole number ratio, we get an empirical formula of CH3. Likewise, NO2 is a molecular formula. Notice, however, that in this case, we are already in the smallest whole number ratio, so our empirical formula is also NO2. Sometimes the molecular formula is also the empirical formula. Let's look at an example that will allow us to calculate the empirical formula of an oxide. Take a second and read the question to yourself. The first thing we're going to want to do to solve this problem is convert our masses to moles, since we're looking for a mole ratio between copper and oxygen. We know that we have 2.5 grams of copper, so dividing by the molar mass, we get 0.0394 moles of copper. We also know that our final mass after the oxygen has combined with the copper is 3.13. Therefore, taking the difference between the mass of the copper oxide and just the copper, we find that we have 0.63 grams of oxygen. Converting that to moles by dividing by the molar mass, we get 0.0394 moles of oxygen. Now we can look at the mole ratio. Since it's a 1-to-1 mole ratio, we know that the empirical formula is CuO, 1 mole of copper for every 1 mole of oxygen. A common method for determining empirical molecular formula is combustion analysis. Take a second and read the problem here, then we'll work through it together. Here we're asked for the empirical and the molecular formula. Let's start with the empirical formula. First, let's consider how much carbon was in the original sample. We know that when this sample was burned or combusted, all of the carbon combined with oxygen to form CO2. Therefore, however many moles of CO2 we have will be equal to the moles of carbon in the original sample, since there's 1 mole of carbon in every 1 mole of CO2. Performing this calculation, we find that we formed 0.00745 moles of CO2, which gives us 0.00745 moles of carbon. Repeating this same calculation for hydrogen, we get 0.0186 moles of H2O. Since there's 2 moles of hydrogen in every 1 mole of water, we have to double this, giving us 0.0372 moles of hydrogen. And finally, repeating for nitrogen, we get 0.00744 moles of NO2, and given our 1-to-1 ratio, we get 0.00744 moles of nitrogen then. Now that we have all of our values in moles, we can look at our ratio, which comes out to be 1 to 5 to 1, giving us an empirical formula of CH5N. Now that we have an empirical formula, let's consider how to get our molecular formula. A molecular formula will be some multiple of the empirical formula. In order to convert one to the other, we need the molar mass of the molecular formula, which was given in the problem. First, we're going to calculate the molar mass of the empirical formula. Our CH5N comes out to be 31.06 grams per mole. Then we calculate the ratio of the molecule's molar mass to its empirical formula mass. So if we know our molecular formula has a molar mass of 62.12, if we divide that by our empirical formula mass of 31.06, we know that our molecular formula must be twice that of the empirical formula. So doubling CH5N, we get a molecular formula of C2H10N2. Here's an example to try on your own. Pause the video here, and when you come back, I'll reveal the answer. A hint for this problem. When you're given percentages, assume they're percentages of 100 and just treat them as if they're grams. So 87.4% of nitrogen would be 87.4 grams of nitrogen. Welcome back. Here's what you should have gotten. Our empirical formula came out to be NH2, twice as much hydrogen as nitrogen, and our molecular formula N2H4. That brings us to the end of this video. Let's review our goals. First, we learned to differentiate between empirical and molecular formulas. Then we learned to calculate empirical formulas from lab data. And finally, we learned to calculate molecular formulas from lab data.